Good afternoon and welcome to NORR. I want to extend a warm welcome to all of the Toronto and Ottawa NORR staff that are joining us. And in particular, I want to welcome the furloughed NORR staff, some of which are also on the line. And in addition to that, we have invited some of the Ellis Don New Toronto Courthouse staff and Ellis Don who may be joining us. I hope all of you are healthy and doing well in your new offices at home and your new environment, and you're adapting as all of us are. At the beginning of the year, I restructured the NORR into 3 series. And as you can see from the first slide, the first one was our engineering series, and we had David Bowick join us at the office. The second one was the master series, and Molly Scott from Knoll talked about the design story for Knoll. And today we have the architectural series, and we have Antoine Chai from RPBW, who is going to talk about Manhattanville, Columbia University. And I'd like to just digress a little bit. I met Antoine Chai just over a year ago, and he replaced Antonio Belvedere from RPBW, who had left the firm. And Antoine quickly took control of the new Toronto Courthouse as the new principal in charge for RPBW, and very late in the game, according to Ellis Don and IO, made some fairly major design changes to the project. And I have to tell you that he was quite exceptional in making those changes, and certainly won the respect of Ellis Don, IO, and our respect, and continues to lead the RPBW team on the new Toronto Courthouse. Antoine Chai is an architect, and he's based in the Paris office. He was born in Lebanon in 1960. Antoine studied architecture at the Holy Spirit University in Kaslik in Lebanon, and after graduating joined the Paris office in 1987. He's worked as a lead architect on a variety of projects, including the Kanak Cultural Center in New Caledonia, a project that, if you have the Renzo Piano book, it's the one that opens in the middle into 4 pages. It's just a fantastic project. He's been elected as a distinguished alumnus at USEK and has been nominated as the patron of the class of young architects in 2017. He received a new distinction in 2018. He is also an honorary member at the Lebanese Green Buildings Council. He has lectured in France, Italy, Denmark, Lebanon, and the USA, including talks at Columbia University's Graduate School of Architecture, as well as the AIA New York and the Middle East. Antoine was appointed member of RPBW board in 2014, and after meeting him and seeing how well he has been leading the new Toronto Courthouse, it was a natural for us this year to invite him to speak about Manhattanville, where he has been working on, next slide please, for an extremely long time. And Antoine has promised me a tour of the building, but I think, Antoine, we're going to have to wait a little bit before we have that tour of the buildings that you've been working on.
We will do it.
So without further ado, I'm going to hand this over to Antoine to present Manhattanville. Antoine.
Hello. Thank you, NORR. Thank you, Silvio, for giving me this opportunity to make this presentation, to talk about architecture as a catalyst of urban renewal. So I will try during this presentation to tell you what an urban campus would mean and how buildings can interact with the neighborhood, I will also try to explain how the architecture as a science help us designing in the context, taking advantage from urban and environmental constraint, and how to design building envelope as a result of dialogue between semantic and function. I would like also to mention that knowing that the fragility of the earth is among the challenges of this millennium, and while sustainability is highly important design factor when we make architecture, other social and civic values are also crucial, such as creating place for people, openness, permeability, and tolerance. So continuing to grow is a requirement of survival to which the major worldwide university cannot escape in order to preserve its place in the race of competitiveness and ranking. Columbia University in the city of New York, this is the real name of Columbia University, who cannot grow on its existing Morningside campus, this is the Morningside campus, choose a new site in Harlem West, 9 blocks to the north, and dedicate the site, dedicate its 17-acre site for a new Manhattan campus to establish an academic and a civic aspiration for a century to come. A kind of vision for a new campus of the 21st century that will be completed in successive phases. So this is the Morning Heights side campus. You can see it here also. And this is Harlem West, 9 blocks to the north, start on 125th Street and always in Broadway. The current one is 116 Broadway, and the new one will be 125th. And here in Manhattan, the location of West Harlem. For the master plan, we team with SOM. Afterward, Columbia University commissioned RPW to develop the phase one. The phase one is this building, 1, 2, 3, 4, the 4 buildings. So for a total of 100,000 square meter that include the 4 first building. The number 1 is the Jerome Greene Science Center that represent the science component of the phase 1. The number 2 is the Lenfest Center of the R that represent the R component. The number 3 is the forum, which is a communication center or conference center, and represent the communication component of phase 1. And the site 4, which will host an academic program that's still under consideration and would include, probably will include the SIPA, School of International and Public Affairs, as well as the Earth Institute. Then we have the 5 and the 6. The 5 is the CEP, the Central Energy Plan of the campus, the phase 1, and including also the phase 2, which is under the number 6, which is the small square. Again, another project completely open to the neighborhood. And this represents the community component of the phase 1. Then we have the number 7, which is outside of the phase 1, and Columbia University decided to commission also to ask us to design this as a residential program. And right now we are finalizing the construction document. The excavation are scheduled for September 2020. That means in 2-3 months from now. Designing a master plan, it's not only about making volume, but conveying the soul of the place. The sense of belonging to a campus, already with the first buildings of the new campus, was an essential challenge for us. the right balance between mixed function. For this reason, I was saying this building is this component to explain that is about mixed function, and the right balance in between is crucial to generate enough critical mass and urban life to achieve this essential goal. With the first building with science, art, communication, community, energy, and global issues, all these things, including the number 7, which is a residential, will give immediately with the phase 1 the sense of new campus, and not only adding a new building 9 blocks from the current one. I think Lee Bollinger, the president of Columbia, asked us, he would like immediately with phase 1 to feel that he is a new campus and not in addition to the existing one. So the Manhattanville campus environmentally sustainable design has earned the LEED Platinum for neighborhood development in 2012. This is the first LEED neighborhood development platinum certification in New York City, as well as the first platinum certification for a university campus plan nationally. This is the current Morningside Heights campus, the current one. This campus represents the value of the last century. That means this campus is gated. You have a gate, you have to go through this gate to go enter, security, and all buildings are made with stone, sitting massively on ground, because this was the way that we built one in the last century. The new master plan is completely different story. The new Manhattan campus represents the value of this century. That means permeability, transparency, and sharing space with others, especially with the city. And this is what I meant, architecture as catalyst in urban real. How buildings are completely open to the city, completely permeable. Anyone in the neighborhood can go in any street from this new campus. Any car can enter in any street. Any citizen from the neighborhood can go into any ground floor of any building. No one will ask them the ID. They will ask you ID if you want to go to the up of the building, to the upstairs, to the upper level. But you can go in all ground floor in any building and be part of the experience in the building. So buildings are sitting on the floor without taking possession of the ground floor. So that the ground floor that we call the urban layer becomes a unifying layer across the whole campus, creating unity and not uniformity, because not the same, with public access function, and not only for the Columbia University population. This is very important. It generates an urban campus where buildings are actively interacting with the neighborhood as catalysts of the public real. The 3 first buildings are already completed. 3 different envelopes with 3 different material intentionally chosen in order to set the palette for the new campus. The material that express the building function and designed in relation to the urban context, the exterior and the interior environmental context, and as I said, establishing the architectural palette of the new campus. For the first building, the Jerome Greene Science Center, we choose the glass. And then you will understand why we choose the glass. For the second building, which is the Lenfest School of the Art, we choose the aluminum. And for the third building, we choose the concrete. And then later, I will explain why and the goal of that. So this is the first building. The Jerome Greene Science Center is about 45,000 square meter building for work and for research, with 34,000 square meter above grade and 11,000 square meter below grade. It houses the Mortimer Zuckerman Mind-Brain Behavior Institute. That means this building is specialized in the activity of the brain. And this is about a lab. And when you say working place and lab, you say daylight and how people can enjoy working in daylight. So this is a view from a view to the north, from Broadway, showing the building within the urban context, because in other photos, the building will look very, very big. But when you put it in the urban context, you see that it's setting well. So this is the building. Light and transparency as a crystal. This building is made mainly of glass to take advantage from daylight, providing ergonomics and indoor environment comfort to the scientists working inside. So semantic and function are working together in dialogue to serve science. So when you see from outside, you see glass, but you don't see glass and then you have an opaque space inside. If you choose the glass, is really to take advantage from daylight. And when we say glass, is low iron glass, is the maximum of transparency and to take advantage from the light, from the daylight. This is the ground floor level. The opaque program element of what we call the urban layer were pushed to the basement, with the exception of pieces of the core, this part of the core 1, 2, and 3. And here, this is the temporary loading dock that there is supposed to go to the phase 2 when we finish. Then all this area becomes again transparent. So the urban layer becomes highly transparent and active with, as I said, public use function, such as restaurant, cafe. We have the educational center with outreach program. We have recreational center, imaging center open to the community, as well as an exhibition and information space called the Synapse, connecting Broadway to the small square. The urban layer, it's very important element. I said the urban layer is this very transparent and luminous layer connecting and creating unity for the whole new campus, because we will not be designing all building of the new campus. And the only one of the way to give unity, even if the above grade is not the same, is the nature of the urban layer, which is very transparent and luminous. And the height of the urban layer in this building varies from 6 meters to 15 meters at the building corners. And another important element, this is really the contrary is what happened in New York. Usually in New York, all buildings are really built to the limit of the property. So the building is completely taking possession from the ground floor. In this building, we fight for that. It was not given, was not obvious. We fight to have a setback of 3 meters at the ground floor level in order to promote more place for life and for pedestrian-friendly neighborhood. So providing more place for people at the ground to enjoy the urban life. And then a special attention was given to the way that the building is touching the ground without taking possession of it, in keeping permeable and open, in staying permeable and open to the neighborhood. So this phase is the synapses. The synapses is a kind of information space. It's about 420 square meters for enabling the public to connect with the research in the building through immersive and interactive installation like this one you see now. Presentation in a small performance area and LED panel, streaming, social media, updates from the Zuckerman Institute. This opera, this work has been made by Mark Hansen and Laura Kurgan. Then one of the other function was the educational center, which is a kind of periscope of what's happening upstairs. This is the workshop connected to the neighborhood. Is about 150 square meters for neuroscience education for the community, with an outreach program open to 12 schools. So the idea is to receive students, to receive kids with their parents from the neighborhood in this space, and to explain what happened in the building and what science does mean. The space, as you can see, include 6 lab benches with one teacher bench and a media wall. This is another space from the urban layer of the first building always. This is a sort of digital imaging lab working on brain and neuroscience images. That means the scientists inside, they work on images of the brain, and they use this space to also to show what they are producing. And because in this space we had a reverberation problem, we had to deal with acoustic. The idea was to suspend the image that produce and use on acoustic panel, and to use them to correct the acoustic in the building. So they are used as a sound acoustic mitigation suspended from the ceiling. This is the mind-brain behavior, or the Jerome Greene Science Center view from the square. And you can see the height of the urban layer is changing from 6 meters to 15 meters at the 4 corners of the building. The urban layer is also fitted with some canopies, providing shadow. This is on the south side, south, east, and west, providing shadow in the summer, protecting somehow from rain in the winter, but also, architecturally speaking, helping to better balance the human and the urban scale of the building. Without also these elements, the building will be very monumental and will have very heavy urban presence in this area. This is the floor plate of the building. It's 4,000 square meter floor plate. It's very big, very deep. And the way we organize it, it's like, imagine it's like small village. So in village, you have streets, you have larger street, and then you have some place where you sit. So the way that the floor plate is organized, we have 2 axes. The north-south one is mainly for circulation, on which we have all vertical transportation. We have stairs and we have the elevators. And then we have another axis, east-west, an area we call an active area. And in this space, we have informal meeting space for the scientists. We have some break space where they can come, take coffee, and have some informal discussion. And then we have some enclosed, small, medium, and very large meetings room. In addition to this, in the 4 corners of the building, we have what we call interactive space. This is also a space where the scientists can come and have also between them an informal discussion. This is the north-south circulation axis when you get from the elevator, with always in these axes, we have always a view to outside. So we are not walking in a maze, a sort of maze that you don't know where you are. You always know where you are because you have inside to outside. This is an axonometric of the floor plate, showing again the working station around the perimeter. It was very important decision to put the working station so people can take advantage from the daylight. This is what I said in the beginning. This building is made with glass to take advantage from the daylight. So we put people around the perimeter an open space to take advantage from the daylight. And we use the middle of the building for support space for spaces that they don't need daylight. And as you can see, the two axes north-south, this is for circulation, the east-west for interactive space. And you see also the four other interactive space are located at the corner, and two of them at the diagonal, this one and that one, they are connected with the level below with a convenient stair to enhance connectivity between level and also enhance the team working between scientists. This is the view of the stair that is connecting the double height at the building corner. The quad, well, I mean the two axes are dividing the floor plate to four quad like that one. So we have the working area around the perimeter, as I said, and the support space in the dark where we don't need necessarily the light. The lab unit, benches, desk, shelves with integrated direct and indirect lighting system are all custom and designed at all. And of course, several different mock-ups were developed to review and to confirm with the end user representative ergonomics, materials, color, and finish. And I can assure you, we had one complete floor, and we did this mock-up something like 5 times, changing the height, changing detail, changing the texture, changing the color, a bit dark, a bit lighter, and then the direct light and the indirect light. And it was very, very useful tools. By the way, this is one of the characteristics of our work, that we work with the user, we work with the client on scale 1-to-1 mock-up in order to verify the design. I put this image really as a tribute to Tom Jessel. Tom Jessel is this scientist from Columbia University who passed away, and he was our end user representative during the process. He was really involved in every detail in the project, every detail, going from functionality to material to colors in the project. And in order to us, to the design team, to get familiar with the lab space working environment and to better understand the user requirement, Tom Jessel invited me with my team to his lab to perform a PCR, polymerase chain reaction, in the lab. So we came one afternoon and we spent the whole afternoon, and each one from us did the PCR, experienced himself with the microscope to the end, take picture and see the result of the work, just to understand how people work in this space. This is a east-west section on the building through the active area, showing the double height space. In the active area, every 2 floors we have double height space, so people can enjoy from the space. And as well as on the 9th floor, on the top of the building, we have a lecture room for about 140 people. And from this lecture room, you have a site on the Hudson River from one side. And to the back, you can see the city with also this tree that we plant on the terrace of the 8th floor. This is a plan and a section on the interactive space, showing that in this area here, on the 2 edges, we have double height space. And then, for example, in this area, we have a medium meeting room, and here we have very large meeting room. All these partitions are completely glass and transparent. So when the space is not used, you can see from outside to outside through this space, and I will show you some images. And here, this is the section below showing the double height on the 2 edges. In the middle, you have the north-south circulation axis. So this is a photo showing the space, the interactive space from the double height, and you see that the double height are connecting. There is stairs connecting the 2 levels together. Always upstairs and below, we have always a meeting space. This is from below, showing the double height space and the connectivity between levels. Again, another image from the meeting rooms looking to the Hudson River, and you see that the transparent is, the space is very transparent. By the way, all these glass partitions are fitted with an automated screen, and we explain to people that when is not needed, please keep it open, and then they play the game, and everyone, and very often when I'm there, you have meetings, you have very large meeting, and with no shade. So people enjoy looking outside and like being in an aquarium, and they don't care. I mean, they enjoy using the space as it was imagined. Again, I'm showing you a series of images always from this space, and even here we can see that outside we have the viaduct of the elevated subway passing in front of the building. So the building, as I said, is transparent, but also illuminated during the night, as a lantern is illuminated to show the nighttime activity inside the building. The building is designed as a factory, a real machine. A building is designed with science and foresight. While the building's MEP system is connecting to the CEP, I was talking about the CEP, the Central Energy Plant, that feed the phase 1 and then the phase 2 and part of the phase 3 later on, is located in below grade with some mechanical room. But due to the geotechnical condition of the site, previously we had another below grade under this building. But in this area in New York, the rock is very, very deep. Well, not very lucky because we are sort in valley. And one of the value engineering items was to take this basement and to put it just above the urban layer, above the ground floor, partially, and the other part on the roof. So the mechanical is partially in the basement, partially above the ground floor, the opaque area, the blue area that we see from outside, and then the rest is really exposed on the roof. And as you see, these two chimneys, the stacks, are the chimney of the Central Energy Plant. And as you can see, I love to show these images to show how beautiful it is and the attention that has been dedicated to draw and to show this machine as part of the architecture. Unfortunately, not too many people can go there, but this is also it's part of the work that we have to pay attention to. Special attention, as I said, has been dedicated to the organization of the mechanical equipment on the roof. That means the mechanical equipment on the roof are part of the architecture. The roof is not a storage area where you can put what you want and the way that you want. A very special attention has been dedicated in order to organize it. So the lab high plume fans, the air handling unit, the CEP cooling towers, and the boiler fluid, all these things are organized and set to be visually accepted. And as you can see here, also these equipment are part of the building architecture. This axonometry view extract from the BIM model, Building Information Modeling Tools, the Revit. We use Revit for this project, which was used for design, but also for coordination. And because without these tools was quite impossible to achieve what we achieve. And I will explain why. Because here, as you know, we use a comprehensive process of class detection, which help us to achieve some technical challenges, such as compacting the ceiling depth to only 4 feet. 4 feet, that means 1 meter 0.2, 1 meter 20 centimeter, for the structure and MEP package that include ductwork, structure, and so we can provide more headroom in the working space, which allow us to reduce the height of the building, which result in significant cost reduction, because when you reduce the height of the building, you reduce the quantity of the envelope and result in cost. Again, this is the Revit model, which includes several disciplines: electrical, mechanical, the central core and below grade, the structures, the steel structure, the fire protection, the slabs, the plumbing. I think you are quite familiar with all these things. Then we start with the constraint. I was talking in the beginning about urban constraint. The proximity to the elevated subway creates the first important acoustic constraint that the building has to deal with. Now, in addition to the vibration issues, an acoustic mitigation of 50% OITC, outside inside transmission coefficient, was requested, knowing that the subway noises represent 88 decibel at the railway level. On the railway level, we have 88 decibel, and we have to cut 50% of this inside the building. Now, I'm not sure that this will work. We had some trouble later on to try. I will try again. But the idea here is to show you a short movie showing the acoustic noise level with the arrival on the train in front of the building. I will try, and we'll see if you can hear anything. I don't know if you heard something. Anyway, it's very loudy. And this is when you are inside the building, it's completely silent. So we have 50% OITC result, a reduction from 88 decibel to about 44 decibel inside the building. It's just amazing. Now, the sun exposure was the second constraint that the building also has to deal with. In the beginning, I was talking about the architecture as a science. That means when you design a building, you don't only design it beautiful or not beautiful or the architecture just, but also you have to think about science. And here we have four quads, the quad A, B, C, and D, with 5 different typology of facade as response to the exterior environmental condition, sun exposure, acoustic requirement, and noises. So you have the numbers here. You have T1, T2, T3, T4, and T5. The T1 is a single skin fitted only with interior shade system only for glare control, because we don't have direct sun here because this is almost north. The T2, we start to be impacted by noises. So we don't have sun penetration. We don't have solar heat gain issue. We have noises issue. So we add a double skin, always only with interior shade to deal with glare control. The T3, we are combining noise and sun exposure, solar heat gain. So we have the double skin and then a sealed double skin to achieve the 50% OITC. And we have in the middle between the two skin, we have an exterior shade to stop the solar heat gain, motorized shade. And then inside, we have a second shade to deal with glare control. Both are automated. Then the T number 4 in the middle, and because we are in a break area or informal meeting area, the 50%
OITC was not a requirement. So we took away the double skin, and we will be able to live with single skin with a specific assembly, is a triple glazing assembly for a small acoustic mitigation. And then again, you have T3, T3, and then the T5, where we are outside of the noise and we don't have sun exposure, but this is a regular IGU. Now, this section is on the double skin. This section showing that the envelope is fitted with a double automated shade. This is the one inside the cavity and the one inside the space. So the cavity shade stops the solar heat gain, the sun and the soft heat gain, while the interior one is only for glare control. Both are connected to the BMS, the building management system, in order to achieve light harvesting. In the perimeter, to achieve light harvesting in the perimeter of the building and also in the lobby, while providing daylight in the workspace. This section is showing that at the perimeter of the building, we have also perimeter radiant heating. This was to improve the indoor environment comfort, but also was to reduce any potential condensation near the facade, especially in the winter. Then other things you can see in this section is the use of the chilled beams. We have a combination of active and passive chilled beams. And as you know, the chilled beam is about also comfort. Is about, because you don't feel, the combination between active and passive, you don't feel the air on your neck. And because the use of the chilled beams, the air change rate was dramatically reduced by almost 50% compared to an all-air system. This reduction allows for a smaller ductwork in the ceiling and allow us to have a smaller depth in the ceiling, by the way, reducing also the floor-to-floor, which is third in reduction of the overall height in the building and its envelope, and of course, its related cost. So instead of running in the ceiling with duct everywhere, we were running with water, with pipes, and this helped us to reduce the thickness of the ceiling. I will go back to this, but I can mention that the solar shade, the outside one, is 10% openness. The interior one is 3%. Both combined together provide something like 1% in some case, while avoiding the moire effect. We can talk about that later on. This is a photo within the cavity. The cavity is about 16 inches, is about 50 centimeter depth in order to allow maintenance access. Here I would like to talk about the choice of the exterior layer of the glass. The exterior layer is a low iron annealed glass without coating, because the goal of the outer layer is two things. First of all, is stop the noise coming from the first barrier, acoustic barrier coming from the train. And secondly, to protect the shade from wind. Because New York is like other cities, you can have a sunny day, sunny and windy day. And because the shade are connected to the cell on the roof, beyond a certain speed, wind speed, beyond 6-7 meters per second, the cell will ask the shade to go up to avoid destroying the shade. And if you have the sun, so it's not working, you will have solar heat gain. The idea here is, in addition to have the acoustic barrier, is to provide also wind barrier for the shade. So I said the exterior glass, it's very important, low iron anneal the glass without coating, so the building looked very transparent. Why anneal? We avoid the heat strengthening glass in order to avoid any anisotropy effect in the building. You know, many times when you are in front of the building, you see some diagrams, some multicolor diagrams, and this is what we call the anisotropy effect on the glass. We also avoid the tempered glass. So we avoid having frit on the outside. We avoid having hole. We avoid having hole in the glass in order to avoid the temper, in order to avoid any waving issue. So the tempered glass will create waving. The heat strengthening will produce anisotropy, and especially when the glass is in the first layer under the sun. For this reason, we went with, the choice was to go with annealed glass. The facade is a unitized system, fabricated and installed by Enclose. They did an amazing job, really. The unit is composed of 3 modules. That means 3 is 2'7", is 80 centimeter about. So the module is 2'4" by 9 meters. That means 2 floors. And this is very important detail. During the bid, we had Enclose bidding against Gartner, against Perma-Stelisa, West Side. East Side. And then Perma-Stelisa came with a more expensive facade, and they were not able to achieve the design intent that we are showing, the thickness of the mullion that we are showing in our drawings. Enclose, they turned the problem, and they made the calculation on 2 floors, and they said, okay, our unit is not 1 floor, it's 2 floors, so we have some structural continuity between 2 floors, which allow them to reduce the thickness of the mullion, and they only ask something like 3 to 4 millimeter increase in depth, and we give them this, and they get faster insulation, which turn out in saving time and cost, of course, and also meeting the design intent. I was talking about the solar protection. So here you can see the automated shade system with 10% for the cavity shade and 3% of the interior one. And as I said, we can combine both because in some circumstances, 10% and 3% is also not enough. We can combine both. And as you know, sometimes by combining 2 different density, you can have what we call the moire effect, which is very disturbing. We were able to achieve the interior with 5%, but 5 plus 10 equal for a moire effect. In order to avoid the moire effect, we were obliged to go down with the interior shade to 3%. Now, I would like to explain how does work this active double skin. We have a lab, and inside this lab, we have 6 times air change per hour. The air is going to the mesh going from the lab space to the HVAC system, and here the air is 3 times filtered and dehumidified. It's very, very clean air. And what we do usually, we blow up this air in the street. What we decide to do here is this waste exhaust air, we pass it into the cavity and we'll inside the double skin and we'll exit through outlet louvers on the rooftop of the building. So in the summer, it will help keeping the heat outside the building. And in the winter, will preserve the heat inside the building, so we'll keep the cold outside. It's like a coat. We put on the building a coat, transparent coat, working for both acoustic and thermal isolation for the building. the air move inside the cavity with very slow speed is about half a meter per second, is exactly 2 feet per second, is about 0.6 meter per second. Why? Because this, in order to avoid creating vibration in the shade, in the cavity shade, and creating distraction for the scientists. And here, again, we discovered this while working on the performance mock-up, and we reduced the speed in order to avoid any vibration inside the space. Of course, all this work was the result of long design process, including scale one-to-one mock-up. So concept, proportions, materials, and colors are reviewed and discussed with the client, the engineer, and the consultant. And here, these images are in our Genoa. You can see Renzo here. You can see Lee Bollinger with the Columbia University president, his wife, who is an artist and also has opinion about colors in the building. And then the consultant, we have everyone is here. And we did this first mock-up. And then when we finished, we decided to make some substantial changes. We took away the shade from the middle and we said, this is cutting the facade in two, then this needs to go to the top. And we made changes of the color. So the mock-up in our culture is a real tool to improve the design and to also communicate with the end user and with the client. And of course, afterwards, the final prototype will be made and tested by the contractor that has been selected. And I think we have similar experience on the Toronto project. And the same process for the steel structure, which has been, at that time we built the control sample of a node. And this control sample, because this is not simply made with built up section, this piece is cast iron pieces. This is cast iron piece. You can see this would pour the gas. And then in order to control the geometry, how things are connected together, because all these connections are visible from outside, are exposed outside the building. So we did this control sample to control the shape of the cast iron pieces, to define the level of the intimissant paint, but also to check how the intimissant paint could be touched up. And this has been used during the bid in order to talk with the contractor. In the nutshell of the building, as I said, the steel structure element were exposed in order to create or to establish a dialogue between the building and the existing elevating subway structure. So the building and the neighbor, the subway, they have some language together. They are not fighting. They are trying to find a way to live together and to have same language. As you can note, sustainability was obviously part of the design approach without being fashionably expressed. And this results in an annual cost saving of the building of 30%, an energy use saving of 35%, CO2 emission saving of 33% as compared to an ASHRAE baseline buildings. In addition to this, a selection of water fixture allowed to achieve 43% of water savings. And I would like to mention that this building was designed in collaboration with David Brodibond as architect of record in New York. Or the engineer was the JBNB for MEP and WSP for structure, Atelier 10 for sustainability consultant, Lend-Lease as construction manager. And the building opened in spring 2017 and owned a LEED Gold certification. The same year, 2017, the building earned the Engineering Excellence Award nationally. And in 2018, the AIA New York Merit Award. This is again the Jerome Greene Science Center, and we start to discover at the left the Lenfest Center of the Art, which is the second building I would like to talk about. This building is located at the threshold of the new campus. It is about 6,000 square meter building that house the School of the Art and the Wallick Gallery. We have about 5,000 above grade and something like 1,000 in the below grade. This is the second building of the phase one. And as I said, this building represents the art component. It was completed also in spring 2017. So this building is a monolithic massing dictated by the program need. This mass appears to levitate above a highly transparent ground floor, which is again the urban layer, which visually continues with the surrounding outdoor space, including the small square, which seems to extend under the ground floor, lifting up the building to create the place, a place on for the lobby. It's like we pretend that the outside space, what we call the small square, is extended inside the building, but covered by the building. It's like part of the square is covered by the building, and we create inside and the lobby. For this reason, the transparency was a very important issue. As you can see, it's highly transparent and perceived as a natural extension of the small square located just in front. It serves as reception hall as well as event space for art exhibition and music and other things. This is a stacked building program that include, in the bottom, you can see a movie theater or 150-seat film screening room. Then just above, we have the performance flexible space, is 99-seat performance flexible space. Then on the third level, we have the Wallick Art Gallery. And here we have, you can see a glass so you can see outside. And then at the top floor, we have a multi-purpose space for symposia, for reading, for dance rehearsal, exhibition. And this this floor take advantage of the natural light from the overhead skylight. The moment of transparency in the building of the above grade are carefully calibrated. That means we put it where was possible and needed. All venue except the film screening, only the film screening is completely opaque. But all the other buildings, including the performance space, because in the beginning, they asked us to design a black box and took us time, maybe 6 months, to explain to them that it makes sense, even in this, to have a glass window so the director of the performance can take advantage from the city background and can include it in his performance. And if needed, we have a shutter and we can create your black box. So we have even in the performance space, we have glass and view to outside. Of course, in the Wallick Gallery, the same, and the top floor also we have view to the city. This is to show a very simple layout organization. This is the organization of the floor plate. So you see that we have a very large span in this area. It's like this space is used for function. Then we have a support area, include also the entry. And then we have distribution corridor and the core that include vertical circulation, mechanical room, and restroom. So the layout on every floor is exactly the same, and it's very, very simple. The size of the building is almost a square. It's 29 meter by 28 meter. This is the second and the third floor, because as you noted, we are working with double floor always. This is the 150 film screening room. This is from the other one. You will see in the whole building the ceiling is completely exposed in the whole building, including here in the screening and the exhibition and in each space. This is the fourth and the fifth. The fourth is when you have the stage below, and the fifth is where you have the balcony. The performance flexible theater, using the neighborhood background as part of the performance, as you can see here. In addition to provide views from inside to outside, also these windows allow pedestrians to glance activities within the building, especially at night, reinforcing the participation of this building and the university with the surrounding city, with the neighborhood. This was very important. We cannot design buildings that are completely blind and they are not connected with the neighborhood. The facade here is a double skin. We have double skin glass window because we were concerned about some noise coming from the train. We are a bit far away because this is very, very silent space. We didn't take the risk, and we had a double skin. In the middle, we have a shading system, and we have a second blackout shutter inside, which allow us to provide black box configuration when the background of the city is not demanded. These are other possible configuration because we are talking about flexible space that allow for several different configurations that they can use riser, they can use only balcony, they can even use a space for rehearsal. That means they can have only a flat surface with only the balcony, and they can use it for rehearsal. That it's very flexible performance space. Then on the 6th and the 7th floor, we have the Wallet Art Gallery space for art exhibition. And as you can see, and as I said, the ceiling is completely exposed. This is a real exhibition, not a rendering, showing some exhibition in the building. But at your right, you have the daylight coming from outside, and we have two systems of shade in order to really control glare and to reduce the quantity of daylight to 1%. This is another exhibition space. And then we have the rooftop, the 8th floor, which is the multi-purpose space dedicated for symposia, reading, for music, for event, or also for exhibition. And in this space, as I said in the beginning, we are taking advantage from the daylight coming from the overhead skylight. This skylight is fitted with a custom exterior fixed shade that provides sun protection. That means the shade is inclined to protect from the south, while we can capture the light coming from the north. So the shade is inclined, the fixed shade is inclined at 45 degrees. At the same time, the skylight is fitted with another interior motorized shade for lighting control. Because in the exhibition stage, you need to provide 1%. If not, you cannot use it for exhibition. No one will borrow artworks. So we were obliged to provide this glare control and light control in order to use it also as flexible and for exhibition. Now, the facade of this building are made out of painted aluminum panel. As I said, the first building is mainly glass. This building is mainly aluminum panel. The size is 6 meters, is 24 feet, is 6 meters. And acting as a rain screen system with different typology. So you have the typology number 1 is triple or double glazing panel inside a aluminum frame. The typology number 2 is completely opaque aluminum panel cut and punched inside. You will see images for that. The number 3 is panels that include offices, because sometimes we have the mezzanine level and we have offices on the top and the bottom. So we have this typology where we include windows. The typology number 4 is adequate for mechanical room and where we have a louvers instead of having windows. And then the typology number 5, where we have opaque flash panel. So we have the panel are cut and punched, and we have flat panels. We have the same module always, 1.8 meter by 9 meter, filled with different typology, filled with glass or with aluminum panel, cut, punched, or flash. This is a typical fixation detail of the rain screen system. As you can see, is really an industrial design. Again, calling to the industrial soul of the site. When we came, we were looking to the soul of the place, and we noted that the soul of the place, because this area is really surrounded by factory and industrial building, we know that the soul of the place is industrial soul. For this reason, we reflect this in our detail, in our way to design this building. For this reason, all these buildings look like very industrial. And this is here, we have two detail. On the top, you see the opaque facade fixation detail. And in the bottom, you see the detail when you have a triple glazing, you have a windows. This is drawings, and this is piece of the mock-up with it. And you see that what does mean punched, cut and punched, and then you see the very industrial detail of the building. And here again, this you see the unitized system fabricated and installed by Gartner. So this second building is the facade is made by Gartner. As I said, for acoustic reason, we adopt a double glazing for the theater, but we have a triple glazing for this level, which is the art gallery. We have triple glazing for acoustic, but not for, but we don't have a double glazing. We don't have a double skin. For the theater, we have double skin. Above, we have only IGU triple glazing, while on the top we have an IGU double glazing, simple double glazing. And you see at the left the model with the punched panel and the glass panel on the left. Again, here are some images showing the louver inside and showing the detail of the corner, rounded edges corner. This was a big challenge for Gartner, how to do this corner. And I remember in the beginning when they came and show up that the cost was very, very, very high. And we were very surprised, saying, but why this is so high? They said, because we follow the architect detail, and we have to make it in very special to get the right radius. I said, okay, wait, which radius the machine will give us? The next time they come with the radius that come from the machine. That means this is if you put it the machine, this is the minimum. And this is what we adopt, and we achieve something like $500,000 saving. And we said, that's it. The building should be also designed by the machine, not only by the artist. And sometimes we are obliged to change our detail in order to, this is about common sense, I mean. At the ground floor level, at the entry level, we have some articulation. We have this suspended canopy at the entrance level. You can see some detail of the canopy. The steel The steel structure, this is the erection of the steel structure. The building has a steel frame structure with metal decking. To achieve the large column-free open space and achieve a higher headroom, we adopt a castellated beam system. As I said, to emphasize the industrial aspect of the building, we expose the bracing system of the building. So the bracing system, we put it outside the building. Usually you hide it. As we did in the first building, we expose it towards the subway. Here we expose it to outside. So instead of hiding this inside the skin of the building, we put it outside. And all these pieces has been designed by the architect, not only the engineer. And you see that all these pieces, we provide detailed scale 1-to-1 of these pieces, which has been designed to be cast iron pieces. During the bid, we were very much surprised because the only company, the only subcontractor respond with cast iron piece was a Canadian company. Was quite expensive, but I should confess that they were, technically speaking, the only one able to provide us with cast iron pieces huge like that. I should also confess that the cost implication was very, very important. Then we sit around the table with the client and the contractor, and we decide finally to replace the cast iron pieces with built-up section, welded, grinded, and smooth to look like like that. That mean like cast iron pieces. And this was very important value engineering, something like $900,000 or $1 million. Again, the same for this building. The beam rivet was used for both design and coordination. In line with the industrial spirit of the building, as I said, and also the site memories, an exposed ceiling was also adopted in the whole building. And because this is a school of the art, colors was an important, an essential design component. So we intentionally use in a specific, very specific location. For example, in the stairs, we use color that you can see from outside. In the kitchen, also we use color. In some corridor. So in the elevator caps also we use color, as we use also in the theater and in the cinema. Then for this building, we designed it in collaboration always with Davis Prodibond. JDNB was for the MEP, WSP for the structure, and Lend-Lease also as design, as a construction manager. This building is also had a gold certification, and in 2018 earned the AIA Merit Award in New York. And the site review with Renzo and the team is always a good moment for picture. So we have picture with the client, for the contractor, with the team, and they are always unforgettable moment that later on you come and you remember what happened. You remember a good moment, but also tension moment. This is the third building, the forum. This is the third one achieved in the phase one. It complements the first one, the Science Center and the Lenfest Center for the Art, by adding the communication to this palette of functions, to this mix of function represented in the phase one. This is a conference center with an auditorium for 437 seats, and of course, other associated support space, foyer, meeting room, classroom, and offices. Located nearby the elevator subway, again, this building had to deal with acoustic vibration as well as acoustical constraint coming from the subway. So this is a two-story building, quite small, highly transparent ground floor, we call again the urban layer. Given the geotechnical constraint coming from the foundation of the subway, we decide to go only with one single conventional below grade. In fact, we have two good reasons to go with one single. First, we would like to avoid the implication coming at 45 degrees from the foundation of the subway. But secondly, we want to avoid the slurry wall option. By the way, for the two first building in the basement, we have a slurry wall for the whole phase one around. Here, for cost purpose, but also for geotechnical issue, we avoid using the slurry wall. And as you can see in this diagram, the building is divided in two parts. One at your right, the auditorium, nearby the subway, and the left, we have offices and meeting rooms. In the beginning, I was talking about semantic and functions. And when you look at this building, immediately you understand that at your right, you have something opaque because the auditorium should be opaque. And in your left, you have something that can enjoy the daylight because you have offices and meeting room. And this is what the building is expressing. You can see that where you have the auditorium. So we have some windows. These windows correspond to the location of the foyer in the bottom. Here we have the bottom, we have the foyer, and here you have some classroom. But this volume is mainly completely opaque, where this area where we have offices is very transparent. And this is to do with the semantic of the building. When you show this building to someone, he will understand immediately we have two things different without explaining. This is again showing the two parts of the building and showing the highly transparent ground floor, which is completely open for public. So the ground floor is an active level, permeable and open to the neighborhood, in the sense that in addition to the main lobby, we have cafe, exhibit space, you have some university event, but also public use functions. Along this street, along to the south facade, we have some glass awning that help pedestrians from rain and the interior space also from direct sun, as well as helping articulating the scale of the building at the pedestrian level, as we said we did for the first building. So the ground floor is fitted with public access functions. This is very important, open to the neighborhood, not only for Columbia University population. So this space, anyone from Harlem, any person from Harlem can get inside, have coffee, sit inside, having information what happened in the building without showing any ID. And this, for this reason, we call this the ground floor, the urban layer, and this is the main difference between this campus and the old campus, because the old one is gated. This one is completely open to the community. And the reason why I named this presentation architecture as catalyst in the urban and the public realm. This is again about transparency, where you are in the cafe and you look towards the street to the Jerome Greene Science Center, and you see also the subway. This is another view toward the subway, showing that the bracing system is also exposed outside and trying to create dialogue between the neighbor, between the viaduct and the building itself. This just to show the detail that we looked at the subway and we understood that we have to be a little bit more articulated to create similar language. And this is the way that we detail create our detail. In plan, as you can see, you can have also the auditorium and you have the meeting room. So the layout is very simple. And as I told you, here you have some opening this is the foyer that could be used also for event, for dinner, or also could use it for large classroom, because this building is used for university to have big conference, while you can have a small meeting room for small group or larger meeting room. And the second level, we have other spaces, so people can use it for small meetings. For example, here we have classrooms for small for small meetings room, and we have this is larger one. And in the middle here we have an outdoor terrace, so people from the offices and from the auditorium and from the class can go outside if needed, if there are any specific event. Again, semantic and function dialogue together. So the facade reveals the building function, opaque and massivity, concrete facade for the auditorium, transparency and light glass facade to take advantage from the daylight at the left for the offices. The auditorium as this is a CMU, is a block, a CMU box, is really a stupid CMU box, is a concrete blocks. But partially fitted with some wood acoustic panel in order to manage the acoustic inside. So it's academic, nothing special. It's really academic auditorium where you are inside and you are inside a concrete box. But in order to make correction to the acoustic, to avoid the reverberation, you have some absorption or reflecting wood panel. Very simple. These are some detail. This is scale 1:1 hand drawing that I made myself, because I'm still drawings, and we are not excluding hand drawings from our culture, and we spend a lot of time to continue to produce some hand drawing. This is an image from the offices. Again, the offices are very transparent, are fitted with interior shade. But very, very often, people like to keep the transparency from one side to the other side of the building and enjoy also the daylight. The facade is simply a stick system and not unified. This is the only building where, given the size of the building, we adopt a stick system building and installed again by Gartner. The module of the facade is 2.4 by 2.10. The same as the Jerome Greene, so the two buildings are talking together. We tried, knowing that we are a stick and single facade, we don't have double facade system. We create a facade to have dialogue with the Jerome Greene, because they are one beside the other. And in this building, we don't have an exterior shading, so the solar heat gain is stopped by the glass. This is the reason why you can note we use a coated low iron glass with a slightly different color with regard to Jerome Greene. When you're on the street, you look at the two buildings, they have the same language, the same module, but one is slightly darker than the other one because we don't have exterior shade. This was also as value engineering decision. So here, when you are in front of the Jerome Greene, the module of the facade is exactly the module we have inside. And the facade is made with overhang, with also a wing on sides and a wing on the top. It's like a screen of glass. You put it in front of the glass of the facade, and very similar to what we did in the Jerome Greene, but without creating a double skin. The auditorium prefabricated concrete facade panel is a modified rain screen system with a closet cell. So what we did, instead of keeping this cell here open, we closed this cell and we stayed with a modified rain screen system, and we used a spray-on isolation on the interior face of the concrete panel. So we put here the isolation, the sound isolation and thermal isolation for both. This is the building looking from the subway. As I said, the building is quite massive. in order to be protected from reverberation, from sound, and because we don't need daylight in the building. And the opposite here, this is a look, the relationship between the massivity of the auditorium and the transparency of the Jerome Greene Science Center. We developed several different typology of junction, one by one, which added another degree of complexity to the concrete panel, which also the design team and the Canadian fabricator, Le Béton du Lac, who did an amazing job, has to deal with. So for this building, for the concrete, we use the Béton du Lac, and they really made an impressive job dealing with all these different typology of module and dealing with the discrepancy and controlling the surface of the concrete, avoiding, because this is very large flat surface, and under a certain angle of the sun, any imperfection will create shadow, and you will see the distortion and imperfection of the facade. And I should confess, they did an amazing job, and we were very, very happy the way that they control and they dealt with the position of each panel with regard to the other. So this is a view. This is the rendering, not very interesting, but view from 125th Street. And this is the real building, the edge of the building. And we see the relationship between this building, who has a triangle shape, and the first building. And you see that in this third building, the building looked like having a double skin like the MBP, while this is really a single skin. We did it like that because we didn't have to spend money on double skin. It was the way also to create dialogue between the two buildings. The forum was designed in collaboration with Datner Architect as architect of record. We had WSP for MEP, AECOM for structure, Skanska as construction manager. The building opened in fall 2018, and the building earned a LEED Gold certification. We have gold for the three buildings. In 2019, was awarded the AIA Merit Award, as well as the best new building from the Municipal Art Society of New York. The whole phase one, and this is the last image, in 2019, the phase one project received the Urban Land Institute, the ULI Excellence Award in Institutional Development. And thank you.
Thank you, Antoine. That was an excellent presentation.
Maybe long.
No, it was fantastic. Those are three great buildings in a fantastic setting in the master plan. Going to go to Ilana to open up the questions.
Go ahead, don't be shy. If you have any question, don't worry. It's informal.
We must have a question from David Cluzio. He's still on the line, isn't he?
Yeah, I actually have a question for you. And it's not really an architectural one. It's just wondering whether the Harlem community has embraced this building, and is the sort of urban strata being actually incorporated into the surrounding community? How is that working? Is it been a success?
This is an excellent question. Thank you, because during presentation you cannot explain everything. In fact, when we were designing this building, everyone was saying people will be intimidated they will not get in because they are concerned about not being allowed to go in. So we had several actions here. First of all, we create in every building the functions, cafe, restaurant, are not directed by Columbia University, are directed from people, sometimes from Harlem or someone else. So people, they can come and get inside. And also we did some work on materiality. We didn't put marble as finished inside the building. We continued the concrete, the sidewalk concrete. We continued inside the building. We polished only. So we tried to create some frugality inside. But also, for example, in the first building, we create the educational center. And I can assure you that at a certain moment, you can see the line where kids and their parents are waiting to be able to get inside to have a session and to learn about the building. And you can see that in the cafe, you have people from everywhere, not only from Columbia. Having said this, this new campus create also jobs for the neighbor. So people in the neighborhood, they work inside the campus. These are ways to them to and somehow to adopt or to accept this building inside. And as you know, sometimes you need to give time to the time, in the sense that you cannot impose the soul of buildings and a large project like that in 1 or 2 years. Sometimes you need more time to people to get familiar with that. And the first year, maybe we'll have less people. The second year, they will understand. They will come more often. And then in a few years, you will see more and more. And don't forget that the site's still in construction somehow. That means now Columbia start the phase 2, and they are building the business school on site 2. And so you still have some fence. Now in September, we will start working on the site number 0, which is the number 7 on the map I show you in the beginning, which is a residential building. So of course, the fact that it's still site somehow, people, they don't understand where they can get. But at the end, we noted that a lot of people from the neighbor, which they are not Columbia population, they come and they are part of. And by the way, I was impressed during the sometime in the small square. I show you the 3 buildings, and I show you that we create small square. In this small square, sometimes you can find people playing gospel from the neighborhood. They come and they play here. So that means they adopt the space as a common space, is space for the community and not only for Columbia University. I don't know, David.
Yeah, no, that's a great answer. I have to admit, I have been to the site, not that long ago, and I certainly enjoyed my visit there. And you've provided a huge amount of more meaning and depth to my understanding of what was going on there. It's quite a successful complex, I have to say, and I'm looking forward to the rest of it filling out over the years and revisiting it. I echo Silvio's comments. It's a great and inspired presentation. Thank you very much.
Thank you.
Thanks, David. Antoine, can you go over the timeline for the project from the start of the master plan?
Yeah, you know, we started, so the master plan has been approved, if I'm not wrong, in 2006. Then after the approval of the master plan, Columbia decided to move forward with the 2 first buildings, the lab, the neuroscience building, and the School of the Art. And we start designing on something like 2008. And then we finished almost together the two first building in 2012. And we were very lucky because we built these buildings under very favorable economical circumstances, because it was almost de-escalation, not escalation. The costs were very low. And then we continue working on the third building, which is a little bit later on, and we finished on 2017, and then we are supposed to start immediately on the building number 4. The number 4 was put on hold, and Columbia, because they are still working on the academic program, and they asked us to go outside of the phase 1 and to work on the residential tower, which is behind me. I don't know if you can see here. We have a residential tower here and this is 400 feet tall building, residential for Columbia student and faculty member. And we will start excavation, and the excavation was for June 2020. And because the COVID, and because in New York, every site which is not considered primer is stopped, and residential is not priority. So we delayed the excavation to September. So we are supposed to start excavation in September, and then this needs to be quite fast track.
That looks like a very tall structure. How tall is that?
It's 400 feet. 400 feet is what? It's 130 meters, something like that. It's 35 story building. But this is only for Columbia population, for student, faculty member, senior and junior faculty member.
Patty, I thought you had some questions.
I just want to say thank you. It's a great presentation, very, very impressive, and thank you very much.
Thank you. That means everything was clear. So Silvio, I mean,
and believe me, the train was quite noisy when we tried this last week.
Sorry. We tried with Silvio and Elena just before the presentation. We did our best. It's impressive. I was interviewed by the TV at the ground floor, and without paying attention, I was explaining the building, and then the train came. And the lady who was interviewing me, she told me, I don't hear you. What you did, how you did to stop this noise. I said, tell me, I will tell you when you are up. And in fact, then we went up. I chose the corner inside, and she said to me, we would like to have movie with the train coming. And the cameraman was listening to my explanation. The train passed 3 times. I told him, this is the 3rd time. If you would like to have the movie, so you have to be focused on that. And then they understood that they don't hear anything. And I mean, even if you don't hear, I mean, this explains to you the difference between being outside and inside. And what is interesting in this facade, the fact that we created, to solve the acoustic problem, we create another problem, who is the solar heat gain. Usually, when you have very often, you use the double skin mainly to house the exterior shade. So as I said, when you have sunny and windy day, you can deploy the shade, taking advantage also from the protection. So, and because this, and then you have this facade should not be necessarily sealed, but because here we have acoustic problem, the exterior layer has to be completely sealed. If not, we don't have the acoustic mitigation. And because it's sealed, you create solar heat gain. So deploying the shade is not enough because you will transmit to inside the heat. For this reason, we blow inside the air coming from the air handling unit. and this air is 3 times filtered and dehumidified. Very clean. So we blow up inside this cavity the air going up to the outlet on the roof, very, very slowly to not disturb the. So when I explain that the architecture as a science, it's very, very important. So the architecture is not about making jest. You were talking about the Kanaki project in New Caledonia, because I did the competition. I worked on the project and I did by hand all drawings of the competition. And when we start to work on this project, we noted that the site condition is such how that the wind is coming only from one side. And we said the shape of this construction is inspired from the traditional shape they did. So we decided to put the shape like that and to put it back to the wind. So when the wind is coming from here, is doing like that, creating a depression area and extracting the air from inside the construction, achieving the natural ventilation. And this is about science. This is not about creating shape, beautiful or not beautiful. At the end, yes, you have to pay attention, need to be elegant as you want. But the measure that architecture for us, it's also a science. Science, including social and the human science. And when you say human science, for this reason in the beginning, when I said that the value of the century is also creating place for people, creating permeability between the city and the ground floor, creating openness and transparency, but also tolerance. And what does mean tolerance? Tolerance that means everyone can get to your ground floor, and you don't have to show ID. And in some building, you are not allowed to go inside. Immediately you go, they ask the ID, and you cannot go to some function on the ground floor, because many often at the ground floor, what we put offices. We put some space that opaque, and here we pay very much attention to the function that will be in this in the ground floor. I can assure you, we had many discussions with Columbia. Every time they have someone to use this space, they consult with us. We have this person. He would like to do this. What do you think? Is this something that can fit within the master plan? And we have insight on the interior design provided by this guy, because we didn't design all cafe and restaurant, but we have insight on the interior design to be sure that what we are creating is coherent with the spirit of the building.
Antoine, the presentation was a.
Silvio, I do have one more question.
Yeah, go ahead. Go ahead.
And it's about the art gallery facility.
Yes.
I'm kind of quite. I mean, in some ways I'm kind of surprised at how it's laid out, because it seems like there very little community or communal space on each floor. The gallery or the art the auditorium takes up quite a bit of. I mean, the floor plates are very tiny, and so you have a little corridor, and then you're right into the space. There's no real crush space on each of the floors. So yeah. I mean, I can see how you've ended up there, and I'm just wondering if you have any observations on how it's operating and how you were able to make that successful. I guess it's very unexpected way of laying the building out and fitting things together.
Yes. So again, good question. So just to know that Columbia University, they have the Wallach Gallery collection owned by Columbia University. So they have collection, the Wallach Gallery collection, as part of Columbia University. And the Wallach Gallery have two things. Sometimes they host exterior exhibition coming from somewhere else. But this space is also used from time to time for the School of the Arts students to show their work. So sometimes it's used internally to show to make an art exhibition of the student works. but sometimes to show part of the Wallet Gallery collection, and sometimes they host international exhibition coming from somewhere. Recently, they received an exhibition coming from Paris. Another time, I was showing one of the images with, I think, let me show you which one. Famous exhibition. Yeah, that one. You see, this exhibition is posing modernity, and this came from I don't read from here, but this is very famous worldwide exhibition. Came to Colombia and went to this space. So to respond to your question, they have yeah, from time to time they can host other exhibitions.
The question isn't so much about the content, it's just how the building, like, it looks like you have a large space on the ground floor where people would arrive, and I guess that's where you have any kind of breakout.
Yes.
Floor, and then everybody rises up in the elevator, and there seems very little space on the floor because you've got, you know, your tight site. And so there's this kind of, I mean, it's an unusual arrangement for, comparing it to your other building, building number 3, where you have the auditorium and you have quite a lot of breakout space on the floor immediately associated with the auditorium. In this case, that kind of public breakout function that's normally associated with either the auditorium or the performance facility or the screening room is all on the ground floor. And that kind of bifurcation of those two functions that are normally quite close together is quite unusual. And I'm just wondering about how well that works, and are the, you know, the crowds that come very tiny, and so it all works given the scale of it. I mean, just unusual. That's all, I guess.
Yeah, you're right. But this is interior lobby. It's about 20 meter by 20 meter inside, about 400 square meter. Yeah, it's not gigantic, but when you in good weather, works very well between inside and outside, because they can have activity inside with extension to outside. And in some circumstances, I was there and I saw artists creating art directly in the lobby. So that means they are producing their artwork immediately in their lobby. And sometimes you can have piano and you can have some music inside. They can have some symposia or reading. You know, the space is small, but is intensively used by the university, by the School of the Art.
Thank you.
Okay.
Thanks, David. Antoine, on behalf of myself and the firm, I want to thank you. That was a great presentation, and again, it's another tribute to your firm. I think, you know, you've presented 3 buildings, and each one of them is a great building. If I could use that word, people overuse that word sometimes, but they truly are great buildings. And much like most of your work, most of RPBW's work, each building is unique. You know, it's one of the reasons that, you know, we came, you know, in 2013 to, you know, to solicit to want to do the new Toronto courthouse with your firm, because, you know, you treat every single building as a unique building. There's no 2 buildings, even with your 3 buildings. They could have been all 3 the same, but they're not. Each one is unique. Each one is unique for its own reason. And, you know, it's great to have you today take us through the reasons why you did what you did in every single building. And, you know, quite honestly, I certainly admire that with your firm. I admire what you've done. And I think you're a really lucky guy. I mean, you know, to be able to work in a firm that you have and to work on the kind of projects that you have, it must be a real honor to have worked on the kind of projects that you have and continuing to work on projects like you have.
You know,
We're really glad. We're really glad to, to be working with your firm on the new Toronto courthouse right now.
Thank you. We too are very glad to work. Thank you.
Thank you again, and we will definitely, when this whole mess is over, we'll get together and we'll share a glass of wine.
Great. We are looking forward. I'm looking forward. Okay.
Could I have my last slide, please?
Yes. Yeah. Of course. Hello. Your last slide should be this one. Oh. That one.
All right, so for everybody that's still on the line, thank you for staying on. And as you can see, the next NORR is to be determined, but I can tell you that we're probably going to set it at the end of August. The schedule is slightly different than it was, and the next one after that will probably be in September. And for the next one, the presentation is going to be on aerocerenin. And much like the presentations that we've seen today, for those of you who know the works of aerocerenin, he is one of the great architects. And I just you can't see it, but I have a number of books that I have invested on aerocerenin, and one of the ones that I'm holding, which you can't see, is aerocerenin, and it's a book on his own work, which was actually penned by him before he passed away. Aerocerenin had a very short life. He actually passed away when he was 51 years old, and which was obviously unfortunate. And I just want to read two excerpts from the book, and this is him talking about architecture. Essentially, we have an urge to soar great distances with our new materials and to reach upward and outward. In a way, this is man's desire to conquer gravity. All the time, one works, one concerns oneself with the flight against gravity. Everything tends to be too heavy and downward pressing unless one really works at it. Our architecture is too humble. It should be prouder, more aggressive, richer, larger than we see it today. I would like to do my part in expanding that richness. And I'll leave it there. The presentation that I've been working on, and I've been working on it since January, Stephanie Fleming has been helping with the PowerPoint to put it together. I'm going to be covering 14 of his buildings, and believe it or not, he completed those buildings really in the last half of his career. Some of them he never actually saw them being completed, and you know some of the buildings, TWA, Dulles, International, and of course his furniture. So hopefully you'll join in. The presentation will be a little lengthy, but I've done an awful lot of research on him, and unfortunately Rolf has signed off, but he is one of the greatest Finnish American architects, and certainly a great architect of the last century. So hopefully you'll join us for that series on the Master Series. So thank you to everyone for joining us. And for those of you who are architects and need your points, don't forget to fill out the forms. Antoine has completed and has been kind enough to complete the lists for this session. And please fill those in and send the forms to Patricia, and she'll get them into the OAA for your required points for the OAA. So thank you to everyone, and enjoy the afternoon, and thanks again for joining in. Take care.
Thank you.